All right. Let's see. Let's see if we can't condense this math just a little bit. It'd be kind of nice. Okay. So see, I'm having to go to another sheet of paper here. See. All right. What I'm going to do is I'm going to take this part right here. Okay. All right. My starting amount was 7.47 grams of HCl. Put it over 1. I'm going to put the conversion unit here. 1 mole of HCl over 36.461 grams of HCl. Okay. Now, this down here, this is not truly a conversion unit because 1 mole of this doesn't really equal 1 mole of this, but this is a conversion ratio, and it's called the molar ratio. Okay. This is a conversion unit because it does equal 1. But what I can do is, instead of calculating an answer here and then calculate another answer here, I can put the two of these things together. Because when I finish this, I'm going to get this number that I put there. I'm just going to go ahead and plug this up next to it. 1 mole of magnesium hydroxide and 2 moles of HCl. Okay? And watch, this is where cancel as you go really makes a difference. Okay, so this probably sounds terrible on the recording, I don't know. All right, so then we'll cancel those, but look, I can cancel these too. Okay, and I'm only left with moles of magnesium hydroxide, and that's what our problem was asking for. How many moles of magnesium hydroxide will it be needed? Okay, so this will give us the answer as well. All right, now we might round off and get maybe 1/100th difference or something, but that's perfectly okay for this class. All right, so here's what we're going to do. If we're going to do it this way, you need to remember this rule about using your calculator. This is just a faster way of doing calculation on your calculator. You ready? You're going to multiply everything across the top and hit equals. Then you're going to divide by one number on the bottom, hit equals, and divide by the other number on the bottom, hit equals. Okay? That's just a step-by-step process that will get you through this really fast. Now, 7.47 times 1 times 1 just gives you 7.47, right? All right, so we just put that in there and divide by this first number on the bottom, 36.461, hit enter, and then hit divide again by 2, okay? And I get 0.1024.
That's a little bit different than the other one.
It is. I said it might be a little bit different.
Oh my goodness.
Okay. All right, so we need to then round off. Look at the number here, and I've got 3 digits here and 5 digits here. These are both counting numbers, as is this number and this number. So the only numbers that really are used in figuring out significant digits for this multiplication division problem are these two, this measured number and this calculated number. This is the one with the least digits. I want the same number of digits, that's 3. Rounding off from here then, I get 0.102. 4 doesn't round up.
Oh, yeah.
Okay? 2 moles of magnesium, don't want to do that, magnesium hydroxide. Okay? And that is the final answer. Okay? And this one's probably more accurate than that one is, simply because I didn't propagate an error as much.
Yeah.
Okay? Every time you round off, you're propagating an error unless you do it at the very end. Okay? Rounding off it does propagate errors. The problem is you have to round off to show the actual number of significant digits. So there's some shortcomings in any kind of math we're going to do. Okay? And as you get into higher and higher levels of science and math and stuff, then you learn how to handle those things a little better. Any questions about how to do this? All right, then. This shouldn't be too hard. Okay?
Really not. It's just long.
Yeah, that's right. It is long. So,
Very, very long.
okay, but we're going to be, there are some problems in this unit, and you're going to be surprised. When we get this in this unit, you're going to say, I can do this. I can't believe I can do this. Okay? But here's the thing. When there are some problems in this unit where you're going to have to do 3 problems that are longer than this to get the final result. Okay? 3 problems longer than this to get the final result. And a couple of the small little calculations too. All right. So let's give you a homework problem.
Oh, let's not.
Should we do it on paper like this?
I would do it on white paper. I would. Okay.
Where did we start? Started.
I'm writing it out right now. Okay, so here's your homework problem. Okay? If I want to fully react 5.25 grams of sodium phosphate with calcium bromide, what mass of calcium bromide will be needed? Okay? All right, so let me give you a little heads up here on this. Okay? Please.
Yeah, we don't want to get like.
Unless you have hand sanitizer quicker.
No, hand sanitizer. Hand sanitizer may be quicker. It's not as effective as washing your hands.
Kills 99.9% of germs.
Washing your hands is more effective if you do it properly. Now, Jay Breezy, if you really want to be effective in getting the germs off your hands, you'll well, that might do it. But then we have the problem of spreading bloodborne diseases. All right, all right, quiet. You'll sing "Happy Birthday" twice while you're washing your hands.
I heard you saying your ABC.
Who do I sing it to?
We could sing it to Molly because she had a birthday yesterday. All right, now listen, I'm going to give you a heads up about this problem. Please don't throw paper airplanes in my classroom.
That's what I'm saying. I tried to tell them.
All right, listen up. Here's the thing you need to remember. Now, all I've given you is the very basics. You're going to have to, listen. I mean, we're running out of time here. If you really want to just have to do this without my little heads up things, that's fine. All right, listen then. You're given 2 species. You have to figure out the formulas for those species, don't you? You have to figure out their physical states. You have to figure out, you have to predict the products and their physical states to find out if you have a driving force. Okay? Once you know you have a driving force, then you have to balance the formulas on the product side. Okay? Once you get all that done, then, once you balance the formulas, you're ready to balance the equation. That's just, you got to get there just to start on this problem. So you're going to start with this starting amount over 1. You're going to have to calculate molar mass just like we did to find the moles of sodium phosphate. Then a molar ratio to get to the moles of calcium bromide. And I've added an extra step in here because I want you to find the mass of calcium bromide. So you're going to have to find the molar mass of calcium bromide to convert to the mass. You got all that? All right? So we're just taking one extra step right here. Just one extra step. But the step is no different than we did before when we calculated molar mass. Okay, we calculated molar mass a couple times in here. Okay, here's molar mass down here. Okay, you just got to calculate molar mass and build a conversion, the same methodology, the same
You need
system.
to recycle those.
Okay?
You need to recycle those for the environment. You need to recycle those for the environment.
It doesn't work that way.
Over to the left, take it in the trash.
If you go from mass straight to mass, you're not going to have. It won't give you the right answer. Okay, you can't convert directly from mass to mass because it's individual formula units that are reacting together, not mass amounts that are reacting together.